Hello everyone, welcome back to ChemOrgChem. As you know, we have been exploring into problem solving for name reaction featuring organometallics. In last series, we tackled the Heck cross-coupling related problems. In today's session, we are moving on to the Sonogashira cross-coupling reaction. So let's moving to the our reaction. So this is the problem from CSIR 2011. As per this question, iodobenzene reacted with probarhyl alcohol in the presence of palladium tetracase, copper iodide, butyl amine under heating in second step which react with lithium aluminum hydride which produce a product. So here you can see that there are four options are given. Let's solve together to find the correct option for this question. So let's moving to the solution. So first write it down our question. So the first step of the reaction, once you see this reaction condition, most of them get an idea about Sonogashira cross-coupling reaction. Yes, you are correct. So this is the reaction condition for Sonogashira cross-coupling reaction. In our channel, we have already discussed Sonogashira cross-coupling reaction and their mechanism, catalytic cycle and variety of examples. If anyone missed that video, you can find the link in the description box below. So as per Sonogashira cross-coupling reaction, we need palladium tetracase. So for our convenience, we can rename that triphenyl phosphane as L. So the first step of the reaction would be the generation of palladium zero catalysis. So now you can see that, so this palladium complex dissociate into produce palladium zero catalysis. So now this palladium zero catalysis undergo oxidative addition with iodobenzene, so which produce this respective intermediate. At the same time, this probargyl alcohol react with copper iodide and butyl amine, so which produce corresponding copper acetylide intermediate. Now this intermediate and this palladium intermediate undergo by transmetallation reaction to produce this respective intermediate. So which then readily undergo cis trans isomerization to produce this corresponding complex. So which then undergo reductive elimination to produce this corresponding alcohol product along with regeneration of this palladium zero catalysis. So now this alcohol react with lithium aluminum hydride. We know that lithium aluminum hydride, one of the powerful reducing agent which can reduce variety of the functional group including alkyne. So here you can see that lithium aluminum hydride, so initially which readily takes the proton from this hydroxy group, so which readily kick off hydrogen gas to produce this corresponding intermediate. So now you can see that one of the hydride atom transfer into this alkyne, so resulting that this pi bonded electron move towards this carbon to produce this corresponding intermediate. So for our convenience, we can redraw this structure like this. So now you see, so this negative charge so readily attack this aluminum atom to produce this 5-membered ring system. So when this 5-membered ring system interact with water, so which produce this corresponding allylic alcohol product. So here you can see that this particular carbon is electron rich, so which readily abstract the proton from water which produce this respective product. Here the most important point is the generation of trans alkene as a final product. So let's moving to the our question. So as per our discussion, among the four answer, the correct option for this question is option C. That's it for today's problem. I hope this video has helped you to understand this concept. If you enjoyed this session, just give it a thumbs up and share it with your friends. And don't forget to subscribe ChemOrgChem for much more content like this. And finally, thanks for watching. Bye bye.